Graph the function f of x equals 2 cosecant x minus 1. This is what we're going to do. In order to graph a cosecant or a secant for that matter, what you first need to do is graph the exact same thing but use the reciprocal trig function. So I'm going to make a rough draft on this guy right here of f of x equals 2 sine x minus 1. I'll explain why. But 2 sine x minus 1. So I'm going to make this a rough draft. So I'm going to scooch that over there, blah, blah, blah. Okay. Sine starts right here. Okay. Since this is 2 sine x, it's going to peak out at 1 and bottom out at -3 and repeat at 2 pi. Okay. So actually, let me move that dot down here. Let me move that dot down there. Okay. So it's going to start up here, peak out there, hit the inflection point, bottom out there. And the same thing is going to happen backwards. So bottom out there, restart at -pi, peak out there, and hit an inflection point right there. So I am drawing a rough draft right there. Now, the way you draw one of these functions, okay, secant or cosecant, is you use that as a rough draft. Anytime the rough draft hits a midline, that becomes a vertical asymptote for the actual secant or cosecant function. So I'm going to draw a vertical asymptote through each of these inflection points, like that. Okay. Now again, the red line doesn't count. The red line is just my rough draft. This is what counts. What you do is you create parabola-looking figures using the top of your sine function as the minimum and the bottom of your sine function as the maximum. So we're going to put green dots here, and we're going to create parabolas like that. Let me actually use a thicker line to emphasize that this is the one that I really care about. So that happens. Then you bottom out down there. Okay. Remember, the red doesn't count. The red is just my rough draft, my guide. Okay, but this is supposed to look like this when graphed. Something like that is supposed to happen when graphed. So I know the graph that I stole off the internet, probably not the wisest one to use, but it's the green here that matters. The green is the only thing that matters. So when I state the range of the function, I'm only focusing on the green. Okay, so the range of the function, the upper concave up parts are going to exist from 1 on up. So the range is going to include 1 and go on to positive infinity. The bottom part is going to start at -3 and work my way down. Okay, so that means from negative infinity all the way up until -3, union 1 to infinity, and we include -3 and +1. Now, the vertical asymptotes exists at 0. It also exists at pi. It also exists at 2 pi, at -pi, at -2 pi. So basically every single pi. So an equation that will work is, since this is a vertical asymptote, it's going to be x equals, we'll start at pi, and it happens at every integer pi after that or before that. So we will put plus pi k for any integer k. Now technically, I didn't need that pi there. I probably should have just said x equals pi k for any integer k. Too late. I already wrote it out. This isn't wrong. This will work just fine. But yeah, tricky problem, tricky stuff. Graphing these, not for the faint of heart.